Hello everyone, welcome to iitiansgateclasses. So am I audible? Those who are watching this session can respond in chat quickly. Am I audible? Yeah, yes. So let's start today's session. So in today's session, we will start with GATE 2012 Aerospace Engineering Mechanical Vibration Part Solution. So in GATE 2012, there are total 4 questions for 7 marks. Okay, one is for 1 mark, and there are 3 questions for 2 marks. So if you see first question, what it says the logarithmic decrement the logarithmic decrement measured for a viscously damped single degree of freedom system is 0.125. Delta is given. The value of damping factor in percentage closes to. So guys, we know logarithmic decay is approximately equal to what? 2 pi zeta. And what is zeta? Zeta is known as damping ratio or damping factor, right? So guys, from here, if you find zeta is how much? It will be 0.125 divided by 2 pi. Now they asked in percentage, right? So when they asked in percentage, what you have to do? You have to multiply by 100. Check it and tell me the answer, guys. So 0.125 by 2 pi is how much? First tell me zeta in decimal how much it is? Sile how much it will be? It will be 0.199 approximately, right? Not 1.99. Yeah, percentage, which is approximately 2. So it is what? 0.0199. Am I correct? This value is correct or not? Now they asked in percentage. So in percentage means you need to multiply by 100. So when you multiply it by 100, what you get? You will get approximately 1.99 percentage, which is equal to 2%. So D is the correct answer. Everybody, is it clear? Okay, so they didn't ask answer in decimal, they asked answer in percentage. So you need to multiply by 100. Okay. Next question, if you look guys, what it says. Yeah. So this question also very easy question, and they have given so much of information which will not have much of use. So what says the mode shapes of an undamped 2 degree of freedom systems are 1 0.5 transpose and 1 minus 0.675 transpose. The corresponding natural frequencies are 0.45 hertz and 1.245 1.2471 hertz. The maximum amplitude in of vibration of the first degree of freedom due to an initial displacement of 2 1 transpose, right, in and zero initial velocities. So guys, for any free vibration, for any free vibration, the maximum amplitude is equal to what? Can anybody tell? For any free vibration, for any case of free vibration, maximum amplitude will be equal to what? Always maximum amplitude of response always will be equal to what? It will be initial displacement. Okay, so any case of free vibration, it is undamped vibration. Okay, there is no damping also. So in this case, or in any case of free vibration, maximum amplitude of the response will be always equal to what? Initial displacement of that mass. So now they asked what? Maximum amplitude of first degree of freedom. First degree of freedom, right? So first degree of freedom is associated to what? The first mass. And what is the initial displacement for first mass? What is the initial displacement? Mass m1. How much initial displacement of mass m1? It is 2 mm, right? So this will be what? Always maximum amplitude of first degree of freedom. There cannot be any value greater than 2. Now if you want to understand 2 degrees of freedom, okay, system, especially the response of the system. So already in our classes we have discussed, uh, there are few equations which you guys should know. So the first is what? In case of 2 degrees of freedom, if you want to write the response of first degree and second degree, how you can write? Your x1 will be what? X1 for amplitude of mass, m1 for first mode cos of omega n1 t plus x1 for second mode cos of omega n2 t. Then x2 is what? X2 is what? X2. This is what? X1. X2 for first mode cos of omega n1 t plus x2 for second mode cos of omega n2 t. So these are the final response equation when your initial velocities are 0. Okay. With initial displacement they have mentioned, and in case of initial velocities are 0, so these will be the final response for both degrees of freedom. Now guys, at t equal to 0, at t equal to 0, if you substitute in these two equations 1 and 2, what you find? You'll find this x1 is what? X1 at t equal to 0. It is nothing but what? Initial displacement of mass m1. So here it is what? 2. So here cos 0 is 1. So you will get x1 for first mode plus x1 for second mode. So this will be your third equation. Now fourth equation is what? X2 at t equal to 0, what? Initial displacement of mass m2. So it will be what? X2 for first mode plus x2 for second mode. This will be fourth equation. Now guys, further, always in the problem they will mention mode shape or amplitude ratios. So in this case they have mentioned already this modes, right? Phi 1 and phi 2, right? So what is the phi 1? The phi 1 they have mentioned, it is 1 0.5. It is nothing but what? It is x1 for first mode upon x2 for first mode, and this is equal to 1 upon 0.5. Now what is the phi 2? Phi 2 they have mentioned 1 minus 0.65 transpose. So it is what? It is 1 minus 0.675. Okay, and it is nothing but what? X1 for second mode upon x2 for second mode, and it is what? 1 upon minus 0.675. Now guys, there is no role of all this data, because already we know in case of free vibration, the maximum amplitude of any degree of freedom is what? The initial displacement of that initial displacement associated with that degrees of freedom. Now all these are useful when there are other questions in gate exam related to 2 degrees of freedom, or you can see in gate 2022, it's one of the very good questions they asked where all these details are useful. So those who are watching my session first time, they should know what all these details. Now they have mentioned omega n1 and omega n2 also natural frequency, but in gate exam we nowhere we use these natural frequency in case of 2 degrees of freedom problem in any problem. Okay, these are useful if you have to find this phi 1 and phi 2. These are already given, but we know this phi 1 and phi 2 in terms of what? Mass, stiffness, and these natural frequencies if you go through the basic equations. Okay, then so let's move to next problem. What next problem says? Read. The boundary condition of a rod under longitudinal vibration is changed from fixed to fixed free. The fundamental natural frequency of the rod is now k times the original frequency, where k is. So guys, it is the case of vibration of rod, longitudinal vibration. Okay, and both the ends are fixed. So in last class, so we have seen vibration of shaft where both ends were fixed, right? So I told already, when both the ends are fixed, what is your boundary condition? At x equal to 0, what will be u? Anybody? What will be u? At x equal to 0, u will be 0. Same at x equal to L also, u will be 0. So these are my boundary condition. With these boundary condition, we find what is the modes. We found what will be the mode. Mode will be sine n pi by L, right? Sine n pi by L. And this is nothing but this is equal to what? Sine omega by c into x. Yeah, n pi by L into x. This is what? Mode. So this is nothing but sine omega by c into x. So what will be your omega? Your natural frequency? It is n pi by L into c. Okay. Now guys, what is the c? In case of rod, what is c? What is c? It is what? N pi by L under root E by rho. Okay. Is it correct, right? Quickly guys respond. Yes or no? This is correct or not? Okay. Now what will be your first natural frequency? In this case, what will be your first natural frequency? Omega 1 will be pi by L under root E by rho. Now guys, in second case, what they are doing? In second case, what they are doing? They are changing from fixed to fixed free condition. So what will be your boundary condition? It will be u at x equal to 0 is 0, and then dou u by dou x at x equal to L will be 0. Now, when you use this second boundary condition, what will be your natural frequency? It comes to be pi by 2L under root E by rho. You guys can refer Grover book for continuous system, okay, mechanical vibration of continuous system, and there you can see the derivation also. Now omega 2 is what? This. Now what they told in question, what they told, the fundamental natural frequency of the rod is now k times the original frequency, right? So they asked what is the value of k. Now we know initially what is the original frequency, omega 1, and what is the omega 1? It is pi by l under root e by rho. So from here you can see it is nothing but what? Omega 1 by 2. So this is nothing but k times omega 1, which is what? Your original frequency. So what is the k value, guys, now? What is the k value? In this case, what is the k value? 1 by 2, which is nothing but zero point 0.5. So what is the answer? Clear? So it is A is the answer. Everybody, is it clear? A is the answer, yes or no? Yeah. Let's move to next question. What it says? Yeah. Read the question, what it says. A spring mass system is viscously damped with a viscous damping constant C. The energy dissipated per cycle when the system is undergoing a harmonic vibration of x cos omega dt is given by. Now guys, anybody tell what is the omega d here? What is the omega d? It's the damped natural frequency. It is what? Damped natural frequency. So it's a simple question but directly based on formula. If you go again, I'm saying Grover book, and if you go through this chapter, damped free vibration. So in viscous damping also, in viscous damping there is energy dissipated per cycle. There is a topic, and if you read that topic, then you'll find delta E, the energy dissipated per cycle. It will be equal to what? It will be pi 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 c pi c omega d capital X square. What is X? X is amplitude of the vibration. So directly, if you say the answer is what, guys? What is the answer? So direct. It's the answer is A is the answer. Okay, A is the answer. Now I will tell you how it has come. You know, guys, for any small displacement dx, what will be the work done? dw. So dw will be what? The work done due to damping force F into dx. Now we already know, guys, what is the F? F is nothing but Cx dot. F is nothing but Cx dot. So now, guys, if you see what is your dw, dw is what? F into dx by dt into dx. Now you just multiply and divide by dt. Okay, multiply and divide by dt. So what is your equation now? It is f dx by dt square dt. This is what dt. Now we want total work done in a cycle. So you need to integrate. Okay, we need to integrate. It is what? 0 to t. Okay, so now guys, x is already they mentioned what it is, capital X cos of omega d t. Now guys, substitute this, and what will be T? T will be 2 pi omega D. Now substitute dx by dt, which will be what? Dx by dt will be here. We are substituting f, so f is dx by dt, guys. C into dx by dt. It is not f, it should be c. Okay, you guys can see here f is cx dot. Okay, so this is correction, please, guys. It is not f, it is c into dx by dt. It is also c. Now guys, when you differentiate, what you get? Minus x omega d sine omega dt. Now substitute this in this equation and then integrate and then put the limit. What you find? You will find this is what? Total energy dissipated in one cycle, delta E. So what is the delta E? It will come to be pi c omega d capital X square. So that's why, what is the answer? It is A is the answer. A is the answer. Clear? This question is clear. This derivation also, you just refer or any other standard book, you will get this part. Now you guys don't ask me how this integration is done. So you guys just substitute. So what it will be integration? If I write here, my delta E will be 0 to 2 pi by omega d, and it is c capital X square, okay, omega d square, and then it will be sine square omega d. Sorry, you can write here better. It is what? C capital X square, okay, then omega d square sine square omega dt, and then integration multiplied by dt. Integrate it and substitute your limit, you will find the answer, which is what? Pi c omega d x square. So let's move to next question. Yeah, so those many question only in GATE 2012. Now we will start GATE 2013 paper. So in GATE 2013 paper, from mechanical vibration, there is only one question. There is only one question, and it is only for 1 mark. So guys, see, in this particular paper, they didn't ask much from vibration. So what is the question? What they asked? Read the question. A damped single degree of freedom system is vibrating under a harmonic excitation with an amplitude ratio of 2.5 at resonance. The damping ratio of the system is. So guys, first, it's a this problem is from forced vibration, and they told amplitude ratio. So amplitude ratio, guys, is nothing but it is x by x static. Okay, x by x static is nothing but your amplitude ratio, and it is given as 2.5. And we know, guys, at resonance, at resonance, what is the amplitude ratio? This x by x static, which is again known as what? Magnification factor. It is what? It will come out to be what? Anybody? At resonance, it is what? X by x static will be 1 upon 2 zeta. It is 1 upon 2 zeta, and it is also known as quality factor. In last session, we have seen or I think last to last, there is a quality factor problem. So the amplitude ratio at resonance is known as quality factor, right? Yes or no, guys? Anybody can respond? Okay, so now guys, uh, they are given everything. They asked what zeta. So what will be zeta? So zeta will be 1 upon 2 into 2.5. So it is 1 upon 5. So 1 upon 5 is what? 0.02. So what is the answer? The answer is what? Zeta equal to 0.02. Clear everyone? 1 upon 5, not 0.02, it is zero point 0.2. Please check guys calculation. Uh, Sorry, here 1.5, 1 by 5 is zero point 0.2, right? Yeah, 10 by 5, 2, so zero point 0.5, correct. So zeta is zero point 0.2. I also do lot of silly mistakes. Guys, be careful. Okay. So the answer is zero point 0.2, not 0.2. Clear? Ashish, is it clear? Swastik, others? So basically, if you want to know what is X static, anybody? X static is nothing but what? Can anyone tell? What is X static? It will be F naught by K. What is F naught? We know the force excitations will be what? F naught sine omega t. Okay? F naught sine omega t. So F naught is what? Amplitude of excitation. And omega is what? Excitation frequency. So X static is what? F naught by K. Usually we know amplitude of steady state response of forced vibration is given by what? F naught by K upon under root 1 minus omega by omega n whole square, then square, plus 2 zeta omega by omega n square. So guys, from this equation only we got what? At resonance, x by x static is nothing but 1 upon 2 zeta. This is also known as a what? Quality factor. Okay, clear? Everybody, is it clear? Yes or no? Okay, so let's move to next year. There is this because in 2013 there was only one question. So next in GATE 2014, from mechanical vibration, there are total four questions. Two questions for 1 marks and two for 2 marks. Okay, so the weightage is 6 marks here. So read first question what it says. A damned single degree of freedom system whose undamped natural frequencies omega n is given as 10 hertz is subjected to sinusoidal external force. Power is half of the maximum for two frequencies of 60.9469 radian per second and 64.7168 radian per second. The damping factor associated with the vibrating system in percentage. So guys, in this case, what is this? These two frequencies. These two frequencies are corresponding to what? Half power point. Half power point. This is another concepts in forced vibration. Okay, you guys can go and read. So half power point. So we know, guys, bandwidth. So bandwidth is always given by what, guys? It is given by omega 2 minus omega 1 upon omega n, and bandwidth is equal to what? Always 2 zeta. Now, guys, in given problem, they gave omega 1 and omega 2 in radian per second, but they gave omega n in hertz. So first we need to find omega n, which will be what? 2 pi f z. Okay, fn. Okay, it is 2 pi fn. Now, guys, uh, what is frequency? It is given as 10 hertz. So what will be omega n? It will be 20 pi radian per second. Now substitute everything, guys. And what is arcs? Zeta. So first find zeta in decimal, then we will convert it to percentage. So when you find zeta, what will be zeta? Theta is equal to omega 2 minus omega 1 by omega n. Okay, and it is like omega 2 minus omega 1 by 2 omega n. Okay, now omega 2 and omega 1 are given. So what is omega 2 value is given? What is omega 2 value is given? Omega 2 is given as 64.7168. So 64.7168 minus, what is omega 1? It is 60.9469. 60 point. So it is 60.9469 upon 20 pi. If you guys solve, how much you guys get? Anybody can do this calculation? So you'll get 0.03 around. Please check how much you guys are getting. So guys, if you are finding this session useful, can thumbs up to this session. Okay, good. 0.03. Now they asked answer in percentage. So what? We need to multiply it by what? 100. So the answer will be in percentage. So when you multiply by 100, how much? It will be 3%. So what is answer? 3 is your answer. 3% is your answer. Swastik. Now logically you think, can you have damping ratio of value 30 and system is underdamped? Is it possible for underdamped system to have 30 percentage you are writing? Swastik and others. Ashish, 30 percentage. So 30% means 30 by 100, 0.3. Okay, percentage it is 3. Okay, I thought it is in numerical value. So it is 30 or 3 percentage. Still check. It's not 30 percentage. It's a 3 percentage. I was thinking it Like the numerical value as 30 percentage you have written, but it is Ashish, it's a 3 percentage or 30 percentage. So I think it should be 3 percentage. Okay, done. So let's move to next question. What it is? Read this question. The boundary condition for a rod with circular cross section under torsional vibration are changed from fixed free to fixed fixed. Okay. The fundamental natural frequency of the fixed rod is k times the fixed free rod. Now, guys, we already know, and I have told in previous problem also. Whenever you have a fixed condition, and either it is a longitudinal vibration or torsional vibration. For fixed boundary condition, what is your natural frequency? It is I by L into C, right? Pi by L into C. Now, if you have a fixed free condition, what will be natural frequency? It is pi by 2L into C. What is C? C is velocity of wave propagation. Now, what they asked here, guys, they asked here the ratio of fixed case to fixed free, right? So in this problem, what they asked, omega 1 by omega 2. So guys, what is omega 1 by omega 2? How much it will be? It will be pi by L into C upon pi by 2L into C. So which is nothing but 2, right? So what is the K value? They told omega 1 in terms of omega 2. So it is what? 2 times omega. So what is the K value? What is the K value? K will be. So what is the answer? So guys, be careful how the ratio they want to take. In the previous problem, it was just reverse. Okay, they asked for fixed case your frequency in terms of fixed. Now they are asking fixed case frequency in terms of fixed free. Okay, that's why that was 1 by 2 and now it is 2. Okay, so let's move to next question. What it says? Read the question. 1 kg mass is hanging from a spring of stiffness 500 Newton per meter attached to a massless symmetric beam of length zero point 0.6 meter. Moment of inertia about the bending axis I is given as how much? 8.33 into 10 to the power minus 10 meter power 4. And Young's modulus E is 210 gigapascal as shown in the figure. The fundamental natural frequency in radian per second of the system is. So guys, first in this system what you see, there is a cantilever beam and at the tip of the cantilever beam there is a spring and then mass is connected. So I am asking one simple question. This cantilever beam with spring is in what kind of combination? Series or parallel? Can anybody answer? The given combination is in series or parallel? Sahil, Swastik. It is in series, right? It is in series. Why it is in series? Because you can see the mass is not directly connected with this cantilever. When you have parallel combination means the mass need to be connected at common point. We see, right, the parallel combination means this kind of where you have mass, but series means one spring and then another spring, then this is connected. So this is known as parallel. So Swastik, please check, you are wrong. It's not parallel combination. It is what? Series combination. Clear? Now guys, we already know how to solve this problem. What they ask this question: fundamental natural frequency of the system. They ask what? Fundamental natural frequency of the system. Now suppose I make an equivalent system of this, equivalent spring mass system, where you have a spring which is K equivalent and then mass. Okay. So what will be natural frequency? For this simple system, natural frequency will be what? Omega n, and which will be under root K equivalent by M. So what is here important to find? K equivalent. And whenever you have a series combination, we know guys what? K equivalent is what usually? K equivalent is what? K1, K2 by K1 plus K2. Am I correct for series combination? Yes or no? Here, what is K1? K1 is what? K cantilever beam. And we know, guys, for a cantilever beam, when we consider the entire mass is concentrated at the tip, what will be KB? It will be 3EI by LQ. What is K2? K2 is given as K. Okay. Now guys, substitute everything. They have given E value, they given I value, they given length of the cantilever beam. So what will be K1? Just substitute all the values and find out how much. It should come around 2429.58 Newton per meter. Guys, check out. Is it correct or not? Now, what is the K2 is given? K2 is given as 500 Newton per meter. So from here, if you find K equivalent, how much K equivalent will come? I have the value. So my K equivalent will be coming as, anybody find out what will be K equivalent quickly? And further, my omega n is nothing but K equivalent by M. So it will be coming as how much? I have the final value, and final value, it is 20.36 radian per second. Now anybody tell what is the K equivalent? Swastik? Is 2429.58 into 500 upon 2429.58 plus 500. So how much K equivalent? K equivalent is how much? 414.66 37. So substitute here 414.667. What is the mass? The mass is given as 1 kg. So Ashish, answer is 20.36 or 23.164. We know the square root of 400 is 20, right? And so what is the answer? Correct answer, Shail, is this correct? 20.36. Natural frequency omega n in this case is how much? 20.36 radian per second. Yes or no? Good. So let's move to next question. Yeah, read this question, guys. Try this question. Yeah, so read this question what it says. A single degree of freedom system is vibrating with initial first cycle amplitude of 5 centimeter. The viscous damping factor associated with the vibrating system is 2%. Vibration amplitude of the fifth cycle is, they asked vibration amplitude of fifth cycle. So what is given? X1 is given, the first amplitude, right? We can say the initial amplitude of first cycle. So they have given the x1. So x1 is how much? 5 centimeter. It is how much given? 5 centimeter. Now guys, what is given? Viscous damping factor. So damping factor here zeta is 2%, which is nothing but what? 2 by 100. So that means 0.0. They also asked what? They asked amplitude of fifth cycle, means they asked what? X 5. So x5 is unknown. So first what we have to find? The number of cycle. The number of cycle. So how we find number of cycle? The final amplitude minus initial amplitude. So how many number of cycle? How many number of cycle, guys? In this case, how many number of cycle it will? It will have 4 cycles. So that's where people do mistake. I will plot it and also I will show you guys. Okay. I'll plot also this and I'll show you guys. So you have total 4 number of cycle. Now we know what is the logarithmic decay delta. So delta is nothing but it is equal to approximately 2 pi zeta, and it will be equal to what? 1 upon n. So it is what? 1 upon 4 ln of x1 by x5. Okay, so guys, from here what we see? We see ln of x1 by x5 will be equal to what? 8 pi zeta. Now x1 by x5 will be what? E power 8 pi zeta. And what will be x5? It will be x1 upon, or you can say x1 into e power x1 into e power minus 8 pi zeta, or you can say x1 into, right? Now what is x1 given? What is the x1? It is 5 centimeter. Okay, e power minus 8 pi into zeta is how much? It is 0.02, right? So everything is known. Find out, guys, x5. Yes, good. So it is 3.02 centimeter. Okay. Now, guys, if you plot it and you want to visualize, okay, so guys, you can tell ki I am wrong or right. Okay, so this is first cycle. So you can see when one cycle got over, one total cycle. Okay, so you can see there is continuously decrement. So this is what your x1, and this will be x2. Okay, then this will be what? X3. This will be x4, and this is x5. Now you guys can see how many cycle happen. This is one cycle, then this is two cycle, this is three cycle, and you can see this is what? Fourth cycle. Clear? No, Swastik, you are wrong. So you guys understood. By plot also we can see when you get x fifth amplitude after total four cycle. Clear? Yes or no? Okay, so that's how also you guys can check it. So this is the one way to check. So our answer is x5 is how much? X5 is 3.02 centimeter. So you do your calculation again. Okay, so that's all from today's session. Thank you guys, and for any inquiry or any gate related course, student can contact to IGC number, or can mail to us, or can visit to our website. Our upcoming batch is from Feb 18th for gate 2025. For those who are passing engineering in 26 also can appear in gate 2025. And you guys can always follow us in Telegram, or you guys can subscribe to our YouTube channel for further updates. So those who are watching this session, if find this session is useful, then can thumbs up to this session. Thank you guys. So next session we have for aircraft. We have for aerodynamics, and it will start in a while. So there will be break at 9 o'clock. Okay, between stability and aerodynamic session. Thank you all.